Page 24, review and assessment. Lesson 3, we're talking about acceleration. The rate at which velocity changes. So remember, velocity changes is acceleration. 12. You can calculate the acceleration of an object moving in a straight line by dividing the blank by the time. So it's the change in speed. So to get acceleration, we need to find the change in speed. So think of it as when you're accelerating, you're going from 0 to 60. Well, the change in speed is 0 to 60, so 60 by the time. So if you can do a 0 to 60 in 4.0, that's pretty fast. The graph below shows the speed of a downhill skier during the period of several seconds. Use the graph to answer question 13. So we're looking at 13, and it says, what is the skier's acceleration? So remember, acceleration is speed divided by time, or rise divided by the run. In this, we can basically pick a point on the graph, let's say 8 meters, and let's say 4 meters, and we can just figure out the slope of this line, or rise over run. So we're taking 8 meters minus 4 meters, but that's a rise of 4, and then so the rise is actually 8 meters per second minus 4 meters per second. And you want to divide that by the run, which is, let's say, 2 seconds minus 1 second. See how we did that? There was 2, and that matched with the 8. Here's the 1, that matched with the 4. And seconds. And then simplify, so then we actually have 4 meters per second divided by 1 second. And that can also be written as 4 meters per second squared. All right, let's go to the next question. A ball is dropped from a window and it takes 2 seconds to reach the ground. It starts from rest and reaches a final speed of 20 meters per second. What's the ball's acceleration? Remember, we talked final speed minus initial speed divided by time. So looking at this equation, what was the final speed? Well, there it says final speed is 20 meters per second. The initial speed, what was that? Doesn't say, but it starts from rest. So its initial speed is 0. And it takes 2 seconds, so we know that. Now we are just doing the math, so we have 20 meters per second divided by 2 seconds. And that equals 10 meters per second squared. All right, final question. In looking at how do you describe the motion of an object, key statement in this unit, the distance versus time graph is for 2 runners in a 50-meter race. Describe the motion of the runners in as much detail as you can. Which runner won the race? And then, well, let's just start there. Let's describe both runners. Looking at this blue line, it's pretty straight, doesn't deviate or change from that. So this one is also pretty straight. So if we say distance, she ran 50 meters in 6 seconds and ran 50 meters in 8 seconds. But when we say it like that, we can say that both runners ran at a constant speed. And then we can say that Jen's average speed was, hang on. Jen's average speed was actually 50 divided by 6. So if we do the math on that, we'll clear this, it's 50 divided by 6, 8.3 repeating, and we can just write it as 8.3 meters per second. Figuring out Anne's, she was 50 meters in 8 seconds. Calculate that out. .25 meters per second. And if we ask who won the race, Jen with her average speed of 8.3 meters per second or Anne's with 6.25 meters per second, it would have been Jen. Jen had the greatest average speed, so she won the race. Going on from there, it asks also, how do you know? Well, she had the greatest average speed. Suppose the graph showed the runner's motion until they came to a stop. Describe how the graph would look or would change. So think about when there is no motion, we talked about that, it would come and curve and level to a horizontal line. Okay, remember, there's no increase in distance, but the time keeps going. Okay, so the line would curve and change to a horizontal line. There we go.